Hello everyone, myself P.Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. Right. So here in today's video session, I am going to discuss about the derivation part of the EMF equation of DC generator. So here in this electrical machine, this EMF equation of DC generator is very important question, important derivation. Okay. So here, we need to discuss the EMF equation of DC generator as well as some problems on the EMF equation of DC generator. Okay. So here, EMF equation of DC generator. So first let us consider phi. So here phi is nothing but flux produced by the each and every pole, means flux per pole. Phi is nothing but flux per pole, and Z is total number of conductors. Z is nothing but total number of the conductors, that is Z, and N speed in RPM. N value is speed in RPM, and P is total number of poles, P is poles, and A total number of parallel paths. Right. So here let us consider phi is flux per pole, Z is total number of the conductors, N speed in RPM, P is poles, A is total number of parallel paths. Right. So here the main principle of DC generator is when a conductor cuts the magnetic field, the EMF will be induced, that is according to Faraday's law. So by using this Faraday's law equation, we need to derive the EMF equation of DC generator, that is E equal to N into d phi by dt. So here first we need to calculate we need to derive the EMF equation for the one conductor, means I am taking only here one conductor. So the total number of turns is 1. So then E equal to what? So 1 into d phi divided by dt is equal to d phi by dt. Here is the EMF equation, E equal to d phi by dt. So what is d phi here? Change in flux, and dt is change in time. So d phi is nothing but change in flux, means the flux produced by the each and every pole. So d phi is nothing but flux produced by the each and every pole. It is represented as a d phi equal to flux produced by the each and every pole, that is phi into P. So this is take as equation 1, and this is equation number 2. And similarly dt is there. So dt is nothing but time required for the one revolution. So dt is nothing but time required for the one revolution, that is dt equal to 60 divided by n is the equation. Let us take as equation number 3. Now substitute equation 2 and equation 3 in equation number 1. So here now we'll get, so E equal to d phi divided by dt, that equal to what is d phi? Phi into P by dt 60 divided by n. Then equal to phi p n divided by 60. So this EMF equation is for the one conductor. For the one conductor, the EMF equation of DC generator is equal to phi p n divided by 60. But in DC generator, all the conductors are connected in parallel. So like this, they are connected in parallel. So these are the total number of the conductors represented by Z, and we are having the A parallel paths. So this A parallel path is represented as a 1 by A, and total number of the conductors are represented by Z, that is into Z. So 1 by A into Z. Now this 1 by A into Z is multiplied with this EMF equation. So that implies E equal to 5Pn divided by 60 into 1 by A into Z. Then E equal to 5ZNP divided by 60A is the EMF equation of DC generator. Okay, here is the EMF equation of DC generator, equal to 5ZNP divided by 60A, right? So here, now in DC generator we are having the two types of the windings here. So first one is lap winding. For this lap winding, the condition is A equal to P. If it is a lap connected winding, A equal to P. Now substitute A equal to P in this equation, we will get E equal to 5ZNP divided by 60A. A is nothing but P. So PP get cancelled, we will get E equal to 5ZN by 60. This is for the lap connected winding. And next one is, we are having wave connected winding. So it is a wave winding. So for this wave winding, the total number of parallel paths are 2. Then substitute A equal to 2 in the EMF equation. So E equal to 5ZNP divided by 60A into 2. Then we will get E equal to 5ZNP divided by 120. Okay, so this is the EMF equation of DC generator. So this EMF equation of DC generator is very, very important question or important derivation. Okay, so now we will discuss the problems on EMF equation of DC generator. Okay, so here I am taking the one problem here. So in this problem, a 4-pole wave-wound generator, has 40 slots and 10 conductors are placed per slot. So means, so here a 4-pole. So we are having 4-pole here. So total number of poles are P equal to 4, and it is a wave wound. So if it is a wave connected, so wave means A equal to 2. If it is a lap means A equal to P. Okay, so it is a wave connected winding means A equal to 2. Generator has a 40 slots and 10 conductors per slot. So by using this condition, we have to calculate the total number of the conductors, that is Z, equal to 40 into total number of the conductor is 10, that is equal to 400 conductors. So for this 4-pole wave wound DC generator, which is having the total 400 conductors here. So then find the generator EMF, that is EG, we need to calculate. Find the generator EMF when the generator is driven at 1200 RPM. So speed is there, N is equal to 1200 RPM and flux phi equal to 0.02 Weber, right? So now we know the equation, EMF equation of DC generator, EG equal to 5ZNP divided by 60A, that equal to, what is phi? 0.02 into Z, 400 into speed 1200 into how many poles? 4 poles are there, divided by 60 into A is 2. Now by solving this equation, we will get 320 volts. So here for this generator, the generated EMF the generated voltage of DC generator is 320 volts. Right? Here is the one problem. And next problem, a 6-pole lap wound armature rotated at 350 rpm is required to generate 300 volt. The useful flux per pole is 0.05 Weber. If the armature has 120 slots, so we need to calculate number of conductors per slot. So here first of all write the given data. So here how many poles are there? 6 poles. So P equal to 6 and it is a lap connected. So lap connected means A equal to P. Then 6. Lap wound armature rated at 350 rpm means speed is there. So 350 rpm is required to generate equal to 300 volts and useful flux phi equal to 0.05 Weber. So flux, if the armature has 120 slots, so here the total number of slots are 120 slots, right? So then we need to calculate the total number of conductors. So here number of conductors per slot we need to calculate. Okay, so before that first find out the Z value. So already we know the equation Eg. So Eg equal to 5 ZNP divided by 60A. By using this equation we need to calculate the Z. So Z is equal to Eg into 60A divided by 5NP. That equal to, what is Eg here? Generated voltage 300 into 60 into A value 6 divided by flux 0.05 into speed 350. How many poles are there? 6 poles. That is equal to, so by solving this equation we will get total number of conductors 1029. Right? The total number of conductors are Z is equal to 1029. But we need to calculate the number of conductors per slot. Okay. So here total how many slots are there? 120. So therefore number of conductors per slot equal to, so total how many conductors are there? 1029 divided by total how many slots? 120. So here by solving this we will get 8.575. This is the total number of conductors per slot. Okay. So these are the some 2 problems on the EMF equation of DC generator. Okay. So thank you one and all.